Good morning. In this video, I'm going to discuss conversion reactor in Aspen Hysys. So let me share the PowerPoint. This would be the coverage of our final exam. Okay, so this is the simple combustion reactor with Aspen Hysys. So basically, we will be burning methane, CH4. We'll be reacting it with oxygen to produce carbon dioxide and water. So this is the problem that we will simulate using Aspen Hysys. So the question is, determine how much energy is available at 5 cubic feet per hour at 60 psig, 25 degrees Celsius, fuel stream that is primarily methane. Air is approximately 80 mole percent nitrogen and 20 mole percent oxygen. And this is at 25 degrees Celsius. So sa tutorial, i-assume natin na yung air ay 1 atmosphere or 101.3 kPa. Okay. Tapos regarding the methane, yung 5 cubic foot per hour na yon, so siguro we're going to use we're going to use 0.472 kilogram per hour instead of 5 cubic feet per hour. Tapos, we're going to assume that the flue gas or the exhaust stream is at 182 degrees Celsius. Tapos, we're going to determine the heat available. Okay, so this is the problem. So let's go to Aspen Hysys. Okay, so I'm going to open a new file. Okay, tapos I'm going to add the components. I'm going to add the components. So first is methane. And then oxygen. And then the first product, carbon dioxide. Notice that there should be no space in the name of carbon dioxide. And then water. Okay. And then finally, nitrogen. Okay. I'm going to use Peng Robinson as the fluid package. Okay. And then since this is a reactor, we need to add the reaction. So I'm going to click reactions. Okay, and then click add reaction. This is a conversion reactor. Combustion reactor is a conversion reactor. So add reaction and close this window. And then click reaction 1. Then add the components. So we have methane and then oxygen carbon dioxide, and finally water. Then let's add the stoichiometric coefficient. Negative pag reactant, so methane is -1. Oxygen is -2. Carbon dioxide is 1. And then sa balance reaction, you're going to produce 2 moles of water. So water is 2. You can check that you have a balance reaction when the balance error is 0. And then we'll assume the base component is methane. Usually it's the air that is in excess. Tapos we're going to assume that the conversion is 100%. So 100, ano? Take note na, this is percentage, not fraction. So it's either 100, 95, etc. Okay. So after this, you add the reaction to the fluid package. So click add to FP. And then another add set to fluid package. Okay, another add to FP. Add set to fluid package. Let me repeat that. Hindi kasi nawawala yung exclamation point. I'm just going to delete this. Okay, I'm going to add another reaction. It's a conversion reaction. Methane, oxygen, carbon dioxide, and water. Because this is -1, -2, 1, and 2. And then 100%. Yun. So the reaction is ready. Okay. Just click add to FP. Add set to fluid package. Yun. Don't leave the reaction if there's something wrong with this portion. It might not work when you go to simulation. So make sure that the reaction have checks. So right now we can proceed to simulation. Okay. So in the simulation, just drag a material stream. Okay, so this one is for methane. So just double click this to enter the composition. So for the composition, methane, it's 100% methane. Just click 1 for methane. Okay. Okay, and then go to conditions. So conditions is the temperature is 25 degrees Celsius for methane. And then the pressure is 515 kPa. This is based on the tutorial. Okay. And then go to kilogram per hour. I'm going to use 0.472 kilogram per hour. You can find this on the tutorial. 0.472 kilogram per hour. Then as you can see, the material stream converges. Kompleto na yung data natin. You can see that you have 0.02942 kilogram mole per hour. And then for every mole of methane, you need 11 moles of air. Pag 10% excess. Just check the mathematics of that. So just multiply this by 11, yun yung gagamitin nating flow rate, kilogram mole per hour flow rate ng air. So that would be 0.324. Anyway. So let's drag another material stream. This time this is for for air, So according to the problem, let's go to the composition. We have 20% oxygen, so that's 0.2, and 80% nitrogen, that's 0.8. Okay. And then let's go to conditions. So the temperature is 25. And then the pressure is 1 atmosphere, so that's 101.3 APA. Okay, and then yung 11 times ng 0.029 kanina, that will give you 0.324. So enter 0.324 in kilogram mole per hour. Okay, so as you can see, the air stream converges. Okay, so what we're going to do next is we're going to lower the pressure of the methane gas by using a bulb. Just drag this. And then we're going to lower the pressure to 1 atmosphere. So this is methane number 1. And then let's call the outlet as 3. And then you go to worksheet to lower the pressure. So 101.3. Okay. So both of these streams, we're going to introduce this to a conversion reactor. You can find the conversion reactor under the columns. So this is the conversion reactor. So just drag this on the white screen. Click on the white screen. So we're going to introduce stream 2 and stream 3 into the conversion reactor. Okay. So we wanted to find out how much heat is produced when you burn methane. Let's call this heat. And then this is the flue gas. Your vapor is your flue gas. This is the liquid portion if we have any liquid. And then we're going to add the reaction, the combustion reaction. Okay. And then we're going to add the temperature. So it is stated in the problem that the temperature is 182 degrees Celsius. Okay, so as you can see, it converges. So you can check the amount of heat. It's around 6.1 kilowatts. It's around 6.1 kilowatts. So if you're going to check the tutorial, it is stated that you have 6.5 kilowatts. So the tutorial and the problem in the PowerPoint are different. So sa tutorial kasi, what he has done is he does not specify the temperature, and then He does not name any heat amount. Okay. So when you don't have any heat amount, yun, this will happen. Ano? So ganito yung nasa tutorial. You have 2,209 kilojoules per hour. And then if you're going to convert this divided by 3,000, 1 hour is 3,006. I wonder where he got the 6.5 kilowatts. Ano? Ito yung nasa tutorial. Of course, there's something wrong with this. Ano? I cannot understand it. Ano? So, you need to assume the temperature of the flue gas, not just like what we done earlier. Okay, pero you can check this. This is the final result of the tutorial. Ano? Pero I think it's much more correct to specify in the design that you have some heat produced, and then you need to specify the temperature. Okay. Yun nga lang, the heat is just around 6.1 kilowatts. Okay, so I hope you understand this conversion reactor. So in the exam, you need to realize that you can add a number of reaction, not only one. You can add 5 or 6. So sa final exam, you expect that you will have several reactions, combustion reactions. So we're going to use this conversion reactor. Okay, so try to answer the final exam so that you will have your final grade. You can check the final grade on your blackboard after answering the final exam. So I guess today is 29. So I'll set the deadline on the 30th.